Hyperbola. Hyperbola is the locus of a point P whose distance from a fixed point S bears a constant ratio E to its distance from the fixed line D. The fixed point S is called focus, the fixed line D is called the directrix, and the constant ratio E is called eccentricity of the hyperbola, where E greater than 1. If PM is perpendicular to the directrix D, then focus directrix property is SP equal to EPM. First we discuss the hyperbola x square upon a square minus y square upon b square equal to 1. The following results are applicable in all the three cases, that is for a equal to b, a greater than b, and a less than b. This hyperbola is symmetric about both the axes and therefore it is symmetric about origin. Every chord of hyperbola through origin is bisected at origin and therefore origin is the center of the hyperbola, that is hyperbola is a central conic. This hyperbola has only two vertices, a0 and minus a0. Hyperbola does not intersect y-axis, but for the sake of symmetry, we consider 2 points 0b and 0 minus b on y-axis. These are not the vertices of hyperbola. Hyperbola has two foci, S a is 0 and S dash minus a is 0. Corresponding directrices are x equal to a upon e and x equal to minus a upon e. The distance between foci is twice a and the distance between directrices is 2a upon e. Here we have taken b square for a square into e square minus 1. Therefore, on rearranging the terms, we get e equal to root of a square plus b square upon a. The length of transverse axis is 2a and the length of conjugate axis is 2b. This hyperbola has two latera recta. Length of each latus rectum is 2b square upon a. Endpoints of latus rectum through the focus S are AE b square upon a and AE minus b square upon a. Hyperbola is a curve of infinite extent. The second hyperbola is conjugate hyperbola. Its equation is y square upon b square minus x square upon a square equal to 1. This is also symmetric about both the axes and therefore symmetric about origin. Here a square equal to b square into e square minus 1. Therefore e equal to root of a square plus b square upon b. This hyperbola has two vertices 0b and 0 minus b. Here foci are 0 plus minus b and corresponding directrices are y equal to plus minus b upon e. Length of transverse axis is 2b and length of conjugate axis is 2a. Also, length of latus rectum equal to 2a square upon b. Parametric equations of hyperbola. To obtain parametric equations of hyperbola x square upon a square minus y square upon b square equal to 1, first we draw a circle whose diameter is transverse axis. Its equation is x square plus y square equal to a square and it is called as auxiliary circle. The parametric equations of hyperbola are x equal to a sec theta and y equal to b tan theta, where 0 degree less than or equal to theta less than 360 degrees. Theta is called as parameter or an eccentric angle. Parametric point P of theta on the hyperbola is P a sec theta b tan theta. Rectangular or equilateral hyperbola. A hyperbola in which length of transverse axis is the same as length of conjugate axis is called as rectangular or equilateral hyperbola. Therefore, its equation is x square minus y square equal to a square. The eccentricity of rectangular hyperbola is root 2. Tangency. Equation of tangent to the hyperbola x square upon a square minus y square upon b square equal to 1 at p x1 y1 on it is xx1 upon a square minus yy1 upon b square equal to 1, whereas tangent at p of theta is x sec theta upon a minus y tan theta upon b equal to 1. The line y equal to mx plus c is tangent to hyperbola if c equal to root of a square m square minus b square or c equal to minus root of a square m square minus b square. If this condition is satisfied, then the point of contact is minus a square m upon c minus b square upon c. Thus, two tangents having slope m can be drawn to hyperbola. Their equations are y equal to mx plus minus root of a square m square minus b square. In general, two tangents can be drawn to hyperbola from a point x1 y1 in the same plane. Their slopes are roots m1 m2 of quadratic equation x1 square minus a square m square minus twice x1 y1 m plus y1 square plus b square equal to 0. The locus of points tangents from which to the hyperbola are at right angles is a circle called as director circle. Its equation is x square plus y square equal to a square minus b square. Normals. Equation of normal to hyperbola x square upon a square minus y square upon b square equal to 1 at p x1 y1 is a square x upon x1 plus b square y upon y1 equal to a square plus b square, whereas normal at p of theta is ax upon sec theta plus by upon tan theta equal to a square plus b square. Properties of hyperbola. Number 1. The difference of focal distances of a point on the hyperbola is equal to the length of transverse axis, that is mod of sp minus s dash p equal to 2a. Second, the product of lengths of the perpendicular segments from the foci on any tangent to the hyperbola x square upon a square minus y square upon b square equal to 1 is b square. Number 3. The locus of foot of perpendicular from a focus to the hyperbola on any tangent is its auxiliary circle, that is x square plus y square equal to a square. Number 4. The intercept of a tangent between its point of contact and the directrix subtends a right angle at the corresponding focus. Number 5. The tangents at the extremities of a focal chord of standard hyperbola meet on the directrix of the hyperbola.